Question number 8 says let the sample space S be 1 through 10. We're going to suppose each outcome is equally likely. We're going to compute the probability of the event E, an even number. So we have 1 through 10, so that's 10 numbers in our sample space. So the probability of an even number, there's going to be 5 numbers that are even, so that's the number of desired outcomes on the top, out of 10. So you're going to reduce that, and that's going to be 1 over 2, so 1/2. Type an integer or a decimal. So we're going to change this to a decimal. This is going to be 0.5, so 50%. Okay, so number 9, for the accompanying data set, we're going to draw a scatter diagram. It says by hand compute the correlation coefficient, which that takes quite a bit. We're going to use it with technology. And it says determine whether there is a linear relationship between X and Y. Okay, so we have a data table. We're going to copy that in Excel. So we're going to follow the same process that we normally use. I'm going to highlight this data. We're going to go to Insert, Chart, Scatter Diagram. So see something looks like a positive trend. I'm going to do trend line. I'm going to do more options. We're going to go down to the bottom, and we're going to do display equation and the R-squared adjusted value. So here's my scatter plot. I'm going to move this so I can kind of see what's going on. Now, looking at the shape, we go through 1 through 8, and it goes up to a height of 25. These only go up to a height of 20. So I'm looking for the pattern 1, 1. We got 2 vertical and then 1. So 1, 1, 2 vertical and then 1. That one looks like it could possibly be. So I would be considering either D or A based on the shape and pattern. Let's look at the position between these. They look fairly close, except these look a little bit higher. So if I look at these two at 6, they're at 12 and 14. What is this counted by? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So count by 2s. So we are 2, 4, 6, 8. These don't look in the right spot. If I come over here, 2, 4, 6, 8, 10, 12, 14. So I would go with graph D. Compute the correlation coefficient. So because this is positive, I know my correlation coefficient will be positive. This is kind of small, kind of hard to see, but the R-squared is what we use to find R, which is the correlation coefficient. We're going to take the square root of this number. Because this is positive, I know it's going to be positive. So 0.8984. I'm just going to take the square root of that. So I will do second square root of 0.8984. This gives me my correlation coefficient, which is 0.9478. It wants me to round to 3 decimal places, so 0.94. The 7 will round up, so 0.948. All right, we're going to determine whether there is a linear relationship between X and Y. So in order to do that, we're going to look at the table. So the number of data values we have, 1, 2, 3, 4, 5. So we're going to go down to n is 5, and we get a critical value of 0.878. So critical value of 0.878. That is less than our correlation coefficient 0.948. So if our actual value is greater than this, then that means it is linear, or at least there's evidence of a linear relationship. So because the correlation coefficient is positive, absolute value of the correlation coefficient is 0.948, is greater than the critical value of, that was 0.878. A positive linear relationship between x and y. So that's how we fill that out.